Hello everyone. Let us look into the fourth program, that is the program for flip-flops. So here we will be dealing with the three flip-flops, that is D flip-flop, SR flip-flop and the JK flip-flop. So here this is a code for a D flip-flop. So D is nothing but the data flip-flop. We have one input, that is D, and you know that in a sequential circuit a clock is required. We get two outputs, that is along with Q we get the complementary output, that is Q bar. Okay, so here inputs D and clock, they are the inputs, and outputs, that is Q bar as well as Q. Okay, so next, coming to the program, so always the changes should take place only at the positive edge of the clock. So in a D flip-flop, whatever input you give, the same will be the output. So Q is equal to D, and we are giving a value to Q bar, that is nothing but the complement of Q. This is the main code, and the test bench code, we can find it here. And the test bench code, what we have done is we have declared the inputs as registers and the output as wires, and we have mapped these variables to the original code, and we have given different values for D, and we have assigned the clock values also, and we have mentioned the time duration for which the signal has to be retained. So let us simulate and let us check the result for a D flip-flop. Select open in terminal, invoke the C shell commands. So these procedures are same for all the programs. So next, simulate it, elaborate it, and check the result for a D flip-flop. So here in a D flip-flop you can see that all the changes, it takes place only at the rising edge of the clock pulse. Initially D is 0, output is also 0, Q bar is 1, and you can see here the input has been changed to 1. So these changes takes place only at the rising edge of the clock. So here Q is equal to 1 and Q bar is equal to 0. Let us run the script file and let us see. The script file is also the same for everything. So here the symbol has been generated, schematic for a D flip-flop has been generated. D is the input, and for every clock pulse we can see the output. So here two outputs we get, one is Q and the complementary of Q, that is using a inverter, we have got Q bar. Meanwhile, you can check the area, power as well as the timing report, and this procedure is same for all the experiments. I'll just show the result here, how much power has been consumed. This report is being generated, and timing report is also obtained. Just go through this. So the gate information, everything you find it here. Similarly, for a JK, okay, before JK flip-flop, let us see SR. See, in a SR flip-flop, the inputs are SR and the clock input, and we have two outputs. So SR, 2 bits are there, so it is declared as a vector 1 down to 0. Initially let us assign the values. If you don't assign, some random value will be taken. So here initially we are assigning Q as 1, and all the changes, it happens only at the rising edge of the clock pulse, and we know the truth table for a SR flip-flop. So for 0 0 the previous state is retained, for 0 1 the output is 0, 1 0, output is 1, for 1 1, the result is high impedance state. This is the main code, and this is the test bench code for a SR flip-flop. So declare input as registers. Okay, and you can see the various the combination of inputs that are given here. Let us simulate this and let us check the result. This procedure is anyways explained. First you have to simulate it. Before that, sorry, you need to compile and see if any errors are there. Then the next step is elaboration. Next, simulate and check the result. So here you can see the result. When input is 0, so the changes happens only at the rising edge of the clock pulse. Initially anyway we have assigned the value as 0. Sorry, the value is assigned as 1. Just see the output here, SR 0. Here the values changes here at the rising edge of the clock pulse. You can see for the 1, just see what is the output. The output is 1. For 0 it is 0. Previous state will be retained. I'm sorry, for 0 the previous state is retained. Then you can see whenever there is a change, the output changes here. Then that is changes happens only at the rising edge of the clock pulse. Even if you change the input here, the output you can see it changes only at the rising edge of the clock pulse. So here you can see when input is 0, the previous state is retained. That is, initially we have assigned the value as 1. When the bit has been changed here, that is 1, but still you can see the result is same, because it changes only at the rising edge. For 0 1 the output is 0. Next 1 0 the output has to be 1, so that changes you can find it only at the rising edge of the clock pulse. Then for 1 1 it is not defined, so even if you have changed the value as 1 1, the changes happens only at the rising edge of the clock pulse here, and you can see it is the high impedance state. Let us see the schematic for a SR flip-flop. So the schematic is being generated here. Meanwhile, you can look into the area timing and power report. So it is generated here. The procedure is similar to the other experiments. Next one is a JK flip-flop. So SR, when the inputs are 1 and 1, we get a high impedance state. Actually, it's not defined. The output is not defined when the inputs are 1 1. To overcome that, we have a JK flip-flop. So here the only changes when the inputs are 1 and 1, it gets toggled. The output actually it gets toggled. Similarly, we have written the test bench code for it. So the procedure is same. I'm not going to explain it again here, because the only change is in the input 1 1. So let me run the program and see the simulated result. Repeat the same procedure again. First step is compilation, then elaboration, simulate and check the result here. So here you can see initially the value is not defined. You can define any values here. So then for 0 the previous state is retained, the value is not defined here. For 0 1 it is 0, for 1 0 it is 1, output is 1, and when the bits are 1 and 1 the output is toggled. Let us look into the schematic. So when this process is being done, the various reports are also being generated. So this is a schematic for a JK flip-flop. So you can look into the various reports and you can analyze it. This is all about the flip-flop program. Thank you.